Yeah. Because I need to give my time, I need to give my brain time to rest, because all the cognitive thinking isn't going to help it recover. So that's what we're trying to figure out with everything. Come on, focus. I need to put a question down. Oh, there we go. All right, can you guys see that okay? Is that better? It's a little darker. All right, so what I want to do for the first chunk is to go over some of the questions you guys have been asking, and then have a chance to wander around and look at some of the work that you guys have been completing, just to give you guys some feedback. So I'll go through this sort of set of questions first. So this one has to deal with the tennis ball serve task. Didn't understand what the force diagrams are meaning. So let me pull up that assessment so you guys can see the questions. We'll go on to Classroom. Work. And we are looking at the tennis serve practice assessment. Really important that you guys get one of the two practice assessments done, so that way you guys have something to reference when you guys do your assessment. Remember, it is open book, so if you have one of those completed and you have some feedback on it, it'll help you answer the questions. I would say actually the better of the two to do would be the rubber band one, because that one's going to be more similar to the assessment you guys will get next week. But I can go through the tennis ball one if you guys are asking. So we were looking at the net force diagrams. So when you guys are doing a net force diagram, what you are looking at is you are trying to explain what the forces acting on an object are. So I have, for example, a tennis ball. Come on and focus. So you have a tennis ball. And the net force diagram is just trying to describe how the forces are acting against each other. Yeah, go ahead, come on. And depending on how the forces act on that object, that's going to then influence then what sort of motion you are going to get. So I should say what type of motion occurs. Let me move it up. Are we good so far? Happy? All right. Just as an FYI, when it comes to this assessment, talking about the net forces, this is an excellence level criteria. So if you don't quite understand net forces, don't worry too much about it if you're not aiming for that excellence. Okay? Are we okay so far? Yes, no? Yeah? Okay. So when we are looking at that practice example with the tennis ball, we have the tennis ball in several different situations, and we are trying to describe what's going on with the height of the ball, the motion of the ball, and the forces acting on that ball. All right? So if we look at this first example here, the tennis ball, I have a tennis ball in my hand. Grab something that looks like, okay, so the tennis ball's in my hand, and we are starting to serve it. But what we're looking at for the observations here is we're looking at the height from where it started from, the speed as our observations. So basically right now it's in my hand, it's not moving, so the speed is 0, and then the height is 0 because there's no change from where it's left my hand. Are we okay with that so far? All right. So the next thing that we're looking at is the kinetic energy. That's 0. The gravitational potential energy is almost 0. The reason why we say almost 0 is that there is obviously some gravitational potential energy because this tennis ball is above the ground and not sitting on the ground. Are we okay with that so far? All right. So if I wanted to do then the net force diagram on it and talking about what's going on with my tennis ball, first off, I'm holding it in my hand. If I didn't have my hand there, would the tennis ball fall down? Yeah, so what that tells me is that I do have a force, and that force going down is that gravitational force. Yeah? So I can show that in my diagram going, I have an arrow going down, and that arrow going down is my gravity. Now this ball isn't falling to the ground. Why is that? I'm holding it, right? And that's going to be providing an opposing force, correct? That opposing force, do you think it's equal to the gravitational force, or do you think it's more, or do you think it's less? It's equal. So the reason, so that's my, that's support from my hand. In this case, both the gravity and the support, these are equal. So say, for example, gravity is exerting like 10 newtons, which is how we'd measure force, onto the tennis ball to push it down, and I'm exerting 10 newtons against it. So that way, when these two balance together, I do, 10 minus 10, my net force is 0. So is my object moving then at that point? No, so it's not moving. And don't worry, I will scan this and I am recording it if people didn't see me recording it. All right, are we okay with that so far? All right, so, and then looking at didn't fully understand what the net force diagrams are. I'll do another one just so you guys can kind of see what I'm referring to. Can I swap it over? Okay. Hold on. I see people shaking their heads now. If you want, you can start looking at the other ones and seeing if you can apply what I've just talked about. Cool. Change it? Yep. Okay. Right, so looking back then at the next step. So with each step of the serve, you should be talking about what the speed of the ball and also what is happening to the height of the ball and also the kinetic and gravitational potential energy. In fact, I think we might have this on our drive as an answer. Let me just check so we can actually see the answered versions of it. Shared drive. So let me just see if we have an answer key so I can show you guys what that looks like. And I'm looking in the wrong spot. What I can do is I can post the answer key if we do have it. The answer? No, it's another copy of the same thing. All right, that's fine. That is fine. Live with it. All right. Okay. So in this case now, we have the ball initially, and now we're preparing for our serve. So the ball is just about to leave the hand to start its journey up. So like it has been smacked and it's starting to do its motion. So thinking about that ball when we're hitting it with the tennis racket, when do you think the ball is going to be at the fastest? When it just gets hit by the tennis racket or somewhere else in the journey? When it's just hit. So when it's just hit, remember you're hitting it with that force, and that's when the ball is going to get that huge amount of force and it's going to be able to go really, really fast. As that ball keeps traveling upward, do you think it's getting faster or slower? Slower. And why? Because of the gravity. So when we're thinking about what's happening, and I'll just do a quick kind of diagram because we were asking about net force diagrams. So when I hit the ball, so just after hitting the ball, I have my tennis ball, and I've given it a massive whack with my tennis racket. So I'm doing like a giant arrow to represent that was a huge force that was smacking that ball. Yeah? Let's say, for example, I hit it with like 50 newtons of force. Is there still gravity acting on it? Yeah. Let's say we'll keep it the same. I like to give imaginary numbers to things just to help kind of think about what's going on. So let's say that's 10 newtons of gravity still pushing down on it. If I was to compare and I did a subtraction, I would have 40 newtons left over because I'm using 10 of my newtons to go against gravity, right? So I still have 40 newtons as my leftover energy or my leftover force, and it's going to go in that upward direction. So that's why the ball is moving upward. You okay with that so far? All right. At this point, that is when the ball is the fastest. So that's the maximum speed. We good? All right. As the ball keeps traveling up, what's happening? It's decreasing the net force. So we're losing some of that net force, some of that energy. So we have our maximum speed, so that's our kinetic energy. What's happening to that kinetic energy? Because it's not just disappearing, it's going somewhere. How am I losing it? If I was in outer space and I hit this tennis ball, would it keep going forever and ever and ever and ever and ever and ever? Yeah, because there's no air resistance. So in this case, as the ball is traveling up, I'm losing some of my kinetic energy because of that air resistance creating heat. Yeah? So as the ball travels, it loses kinetic energy because it is being transformed to heat energy. And that's related to the air resistance that's occurring with the ball. So that transformed to heat energy is the result of the air resistance. Yeah. So then what we notice is that the ball is going to slow down. So I'm going to have less and less of this upward force. So it's going to slow down. Are we okay with that? All right, so if we're looking at this example here, we have it midway through the flight. So do you guys want me to type in this? Yeah. So here it would be at its maximum speed. Here the height would be increasing. Its kinetic energy is increasing or at its maximum. What's its gravitational potential energy? Increasing as well, it's going higher. All right, and then if we were going to draw our tennis ball, we would show it with the giant arrow going up and then a little arrow pushing it down. Yeah. All right, when we get to here, the ball is midway up its flight. So what's its speed doing? Decreasing, because it's starting to slow down as it gets to the top. Is the height still increasing though? Yeah, because it's midway through its flight. Is the kinetic energy increasing or decreasing? Decreasing, because it's getting converted into other energies, right? It's decreasing here. It's getting converted to things like heat. Gravitational potential is increasing. That's what we're seeing. All right, the ball at the top, before it turns around. 0, it stops. What's the height? Maximum. What's the kinetic energy? 0, because it stopped moving. What's the gravitational? Maximum, that's at the height. And then when we're talking about the ball in this case, if I had that guy there standing, momentarily, because it stopped moving, my forces are once again balanced. Yeah? Are we okay with that so far? All right. And then when it starts falling down, what's happening to my speed? Increasing. What's happening to the height? Increasing. Kinetic energy? Increasing again. And then gravitational potential? Decreasing, because now it's coming down. All right. Do we feel a little bit better about that? Okay. Do you guys want me to draw any more of the force diagrams here? Are you guys okay with the idea? So when I'm looking at this ball, I would say, how about I draw them just so that way you guys have them? Yeah? All right. So for step number 2, when it's midway through its flight, and it has just occurred to me, I don't have the document camera up. Click the wrong button. All right, so when it's midway through its flight, it's still traveling upwards, right? So I still have a force that's pushing it up, because I still have some of that energy, and I still have the gravity pushing it down. Is this going to be the same as it was before when it just left the tennis serve? No. So it'd be maybe something like, let's say it's now 30 newtons. And my net force then is still going upwards, but what is it now? Only like 20 newtons. So you see we have less force helping pushing it up. All right? So that's what I would say it looks like mid-flight. When we are at the top, I would say the forces are equal. So this is now 10. Let's say this is now 10. The net force is 0. So it stops moving right now. All right. And now let's say we are starting to have it fall down. So now once it's starting to fall, I'm looking at that's 10 newtons. Let's say I still have a little bit of force now, but it's only like 2 newtons are left over. So what's the net force? It's going to be 8 newtons, and it's going to be going downward. So it's starting to fall. Does that help? Remember the forces and using those diagrams, that is the excellence level. Okay. If you are aiming for the achieved, all you need to do is fill in that description of the speed direction, the height direction, that sort of stuff. All right. Cool. Questions, concerns, comments? Huh? No? I hear miss. Yeah, if you want. Do you guys want me to? I'm just going to have a. Actually, yeah, let me pass out the rubber band assessment so you guys can have a look at it. I'll look at these questions. I think I probably answered some of the questions already. Yeah, you were asking how to. I think I answered these two questions by doing that. Yeah. All right. Let me pass out the rubber band assessment so you guys can have a look at that.